Welcome everyone. Thank you for joining today's webinar. My name is Abby Delaney and I am the marketing manager at BigRep. BigRep is a leading provider of large-scale 3D printers and is helping revolutionize how we produce things. And today we're going to talk about just that, how to revolutionize your architecture and construction business with 3D printed framework. Just a little housekeeping before I introduce our guest speakers today. If you have any questions, feel free to type those into the question box at the bottom of your GoToWebinar control panel. At the end of today's webinar, we will have a short Q&A session where our experts will answer as many questions as we can. If we didn't get to your question, don't worry, we will be sure to follow up with you directly and we will send a summary of all the questions asked as well. So now, without further ado, I will introduce our esteemed presenters today. Jorg Petrie and Tobias Walliser. Jorg is the head of research and applications at Now Lab Innovation, which is part of BigRep. He is responsible for innovating cross-sector customized applications and process solutions for clients and with clients. He has an extensive background in architecture and design. Welcome, Jorg. And our second speaker today is Tobias Walliser. Tobias is a professor of innovative construction and spatial concepts and is vice president of the State Academy of Fine Arts in Stuttgart. He lectures at universities throughout Europe and has won many awards. Welcome, Tobias. We are very honored to have both of you with us today speaking and sharing your expertise and insight into 3D printing within architecture and construction. And with that, I will pass it over to you guys.
Thanks a lot, Abby, for your introduction, and we're gonna start directly into the topic. Thanks for joining us. So yeah, let's start on the first slide, basically going through the presentation now. So just a little introduction on BigRep. We are a startup active since 2014 with 80+ employees right now. With our headquarters here in Berlin, that's where we are right now. Also in Boston and Singapore and New York, we have headquarters, we have locations where we're actually working on the technology. As you can see, we're already in the 3D printing business for quite some time. This was Angela Merkel visiting us on the Hannover Messe in 2015. Observing our first designs in furniture design, so I think it created a lot of buzz and attention on this technology. So I would also like to introduce you to our innovation center, which is part of BigRep. So we are not only focusing on the printers, on the technology itself, we're also looking into the applications. So basically trying to see what can you actually do with the printer, with the technology. And there are these three topics that we always circle around that you see in this trifoil, where basically it's all about an application or a new material or a new process that we develop. So these are the drivers where we actually work with. And we have on one hand the research institutes helping us if we don't have the knowledge in-house, and the brand industry is on the other hand asking for these solutions. We already have an extensive, let's say, collaboration network with companies and research institutes we work together with. So for further detailed information, we can always come back to you. We can always ask us questions on this. But let's start on the construction side of the future. This is really the topic for today. This is why we invited Tobias as an expert to really talk about what's at stake at the moment at the construction industry. And I really like this image, this graph a lot because it shows where the future of the construction site is lying. So everything is connected. We need to bring all the tools together. We have the BIM we're going to talk about. We have VR, AR, basically technology on site. We have the delivery process and the planning, the communities linked. So basically, for sure, today we're going to talk about more about the fabrication itself. So this will be our focus on this, but it gives a very nice overview that all these parts have to work together. These are the main chapters we're going to go through today. So we start with a little intro on new digital craft. Then we go through innovative building construction. We talk about sustainability, and then we are open to further questions from your side. So what is this digital craft actually that we're talking about? We're going to explain that in a very brief way. If you look on the left side, you see the image of a facade that was done in the 30s. It's a tobacco factory in Hamburg, where actually the craftsmanship of laying bricks was utilized to actually create a really unique and identifiable design. On the right hand side, you see techniques that are used right now. Basically, this is a project from Gramazio Cola, who were the first ones to integrate robotics into architecture to bring back this craftsmanship as we know it from the past. So we are convinced that the craftsmanship, when we say digital craftsmanship, is a transformation of this handcraft now to other tools. So the setup or the idea is the same, but actually we're using new tools. We're using the computer and we're linking fabrication directly to these parametric design tools, and therefore we create a new craftsmanship design. How does that relate to 3D printing? One example for that is how a material was kind of generating a new idea in our Now Lab. So exactly, again, you can see this part of the materials taking the lead for a new invention. So we have been looking into concrete casting for quite some time, and we have realized this material that is actually a support material for our prints is water soluble. So the idea was now to say, why don't we use this for the print cast project? We're actually embedding this in the cast, the concrete is solidifying, and afterwards, after the concrete is solidified, we basically actually wash out this part. So you can see the undercuts that you create with this are amazing, so you can afterwards still have new possibilities for design. So, and this ties back again to the 60s. So these walls from Erwin Hauer were very common at that time. He used a lot of this technology, and it shows again the craftsmanship at that point was already there. So we're trying to get back to this point where we have the control over these kind of designs. So looking at Dubai with our partner over there, we have created another, let's say, innovation hub, just like Now Lab, where we designed this part here from Berlin. So the idea is to have a transitional wall from an open to closed concrete wall, and we're utilizing 3D printing for this. So here you can see a first images of this application. We're going to have an extensive design post on this one later on, but you can see already we're also embedding sensor technology into the concrete. So basically there's no need for switches anymore into walls. So all this enabled through 3D printing, enabled through the technology or the product we have on the market now with the BigRep 1. And here you can see the casting elements, which actually created the form, the negative form for the concrete element that you see here. And then the segments were put together to actually form the details. Okay, so we're already arriving at chapter 2. I would like to hand over now to Tobias. We're going to talk about several parametric design examples and fabrication examples in construction industry, basically the state of the art that is already currently happening.
Okay, thank you, Jörg. Actually, this is one of my favorite projects, and it's, I would say, the first building that was designed parametrically, but it was designed by Antonio Gaudi in 1882 without the help of a computer. So parametric design and parametric design thinking is not necessarily related to a computer, but it is related to craftsmanship and to the idea of producing something which has very high quality and is also quite complex in geometry. But in order to achieve this, you need to find rules, to define rules which are the common denominator for everyone working on a project. And in order to achieve this, Gaudi started modeling using plaster models to develop the shapes, but also to develop a process behind the creation of the shapes. And that is something which later on, this is the Mercedes-Benz Museum, which was designed from 2001 onwards and was inaugurated in 2006, where I worked on as an architect for a little bit more than 5 years, where this was a project where we looked to parametric design to create something which becomes a legendary building for a legendary car. The idea was that the great thing about cars is when they're moving, not when they're static. But how do you capture this in a static piece of architecture? So the museum, our idea was that the museum, which is a concrete sculpture, evolves around the cars and basically spins around the cars, creating the feeling that the visitor is moving through the structure as if in a car. And for that, we needed a more complex geometry. And we looked a lot into transformative geometries that starts as a straight wall and then it angles out and becomes more like a diagonal, actually it becomes more like a floor. So a continuation between floor and walls. And for that, we had to start with a 3D model, of course. It's a building which needs the help of a computer, not only to be built, but also to be designed. That building would not have been able to, we would not have been able to design it without the help of the computers. So what we did is we first started modeling everything in 3D. We had a 3D master model, and we also started to set up rules. So you can see in the image, there are lots of circles. These circles are all in different angles. We have a lot of other arcs which are tangentially based on the circles, or we defined some right rectilinear angles. In 48 steps, you can set up the floor plan of this museum, and then it's transformed into a three-dimensional piece. If you walk through the structure, you can see a lot of different geometries, a lot of variation, but everything is based on very strict rules. And that helped us to develop and to make sure the building was built and completed on time. So we broke things down into repetitive elements. The color coding shows what elements are similar. Even for the steel columns, the red elements, we had what we call the mother column, one element which is a longer structure than the actual columns which are built, and you can derive any one of the columns built in the museum from that, just cutting it off at different angles and different positions in the top and in the bottom. So there is a different way of thinking behind it, which allows you to create these type of elements. The question was how to get it built. And the great thing about concrete is concrete can take any shape, but in order to produce it, you have to produce the formwork, which allows you to cast the concrete into that shape. So we're talking about 3 dimensions in terms of geometry, that's one thing, but then out on a construction site, we have some more dimensions. We have to make sure the logistics are working. We have to make sure concrete, it takes 4 weeks to harden. So before that, it needs to be supported. And of course, it needs to be, the concrete formwork needs to be dismantled. First, it needs to be built up, but then after the concrete elements have been cast, it needs to be taken down, which is also something which we learned has to be designed right from the beginning. Otherwise, we know how to build the building, or we know how to build parts of the building, but we have no idea how to actually run the process. What we learned from that project is that the wireframe, our representation of the building in geometry in the computer, is actually a very valuable tool to work with directly to create formwork directly from the wireframe. So what we did is we came up with a system where each of the formwork, of the pieces of the formwork, was cut by a CNC mill. Because in this sort of transformative geometries, there are no right angles, that is pretty clear, but there are also no straight lines. So a couple of the seams, which appear to be straight lines when you look at the building, they're all actually curves, which you can see on the right-hand side in the 2D projection. On the left-hand side, you see all these individual pieces. And what was great, using the help of a CNC machine as a tool to cut it, was also the possibility to already provide little holes for the workers to fix this part of formwork to the construction underneath. And that way we could also control the aesthetics of all the nuts and bolts connecting this to the ground. So it is actually the idea of a connection, something which is a geometry which is more complex than what you usually have, but then also using digital design, using digital tools, the CNC machine, to produce something which creates a very high level of craftsmanship and of quality. And I would say the building is very well known for it. It's more than 10 years old. It still looks really great, and it's been labeled as one of the first buildings of the digital modernism.
Very nice. Thanks, Tobias, on this. This is really your project. You've been generating and you've been working on it. So looking at the process change, so we want to talk a bit more about what Tobias was saying now. So if we look at automotive as an example, they have the advantage compared to the building industry that they have basically the whole process from planning to production in-house. Let's say they know at the end of the production line, of their assembly line, how the product looks like and who's going to build it. In the construction industry, we have a completely different situation, and this is what you were also facing with the Mercedes-Benz Museum. Basically, you have these phases where you're working from one step to the other, a very linear process, which we believe for the times now are outdated. We really need to work on, due to having these new digital tools, to actually re-innovate that. So there's a study from the Fraunhofer where Tobias, you were also involved, which actually analyzes this in a very nice way. So this is the existing, let's say, or used to be existing state. We are right now very much in this BIM situation where we say, okay, there must be a model, a central model, where everything turns around and basically all the participants from execution to design, to the plans, to the design phase already are linked from the beginning. That has the advantage that you're actually bringing in the information from the first stage. And actually, in your case, you told me you had already this master model. I know it because I know the project really well. So we didn't call it BIM yet, or you didn't call it BIM yet, but actually you had the technology already outside. And what you actually then added, and this is something that we hear now a lot about the Industry 4.0. This is exactly what Industry 4.0 is about, now linking this digital fabrication to the design processes. So having this interactive model where everyone is involved, and then actually having a real-time optional building of the data, so a parametric model where everyone can continuously optimize their processes. If we look at the printcast as an idea, so printing formwork, this is exactly where we are tapping in. So where we say you have a digital model at the top right, you can generate any design coordinated with your partners. You're going to print it. You're going to get the formwork out. You're going to probably have to do some post-processing depending on the project we have. You're casting it. You strip the formwork. And in the end, you're actually intending to reuse the part. This is a crucial part we will talk about later when it comes to sustainability, to actually reuse the material. So print a small amount of material that just what you need and reuse it. We did these tests. The first elements are already out. I'm going to go quickly through this. So we already also handed in a patent to actually have a modular system ready, a whole system that is actually working with 3D printing. And you can see here, like just as an example, how basically this more complex geometries can be applied to this formwork. For sure, you can now work with the tools you have at 3D printing and also in digital simulation. So you can optimize your elements according to the pressure you have. That's why we took a column to see where you can say the pressure points or the amount of pressure at the column at the bottom is much higher than at the top. So you could calibrate now your cast system with the 3D printed mesh that is structuring the formwork. For sure, as first use cases, we believe that facades in new buildings can work out with this technology. Maybe we are not yet building the standard load-bearing walls, but we probably will be there soon as well. We come back to this point, but we see the facades as a very, very promising topic to actually work with this. This is a project I worked as well on when I was at UN Studio, and we were testing a lot of repetition again of the elements, the same as what Tobias showed before at the Mercedes-Benz Museum, rotating elements in order to decrease the amount of the elements used. And for sure, if we would have had the technology of 3D printing back then, we could have thought the facade in a complete different manner. There was a big discussion on building this on curtain wall facade from different elements. This was in the end too complex, so the decision in the end was to build it or cast it massive in concrete. So we could cast these elements much more weight efficient, much more better from the geometry in order to save material. Another project which I think describes it really well is the Broad Museum from Diller and Scofidio Renfro from 2015. So you have the serial elements, but on the other hand, the transforming elements are now enabled much easier. So this is our aim, to actually move from a non-standard geometry, which we call it now, to a standard geometry where this can actually be done without further effort or further costs. So the nice positive part about having facades is that they're mainly flat elements, so you can lay them on the ground, have the mold on the ground and cast them directly. Another project we worked on, this was actually a direct contract from Geiger. It's a company in south of Germany. They did this building, which is a monument right now. And we had to replace these handcrafted from masonry made windows. Luckily, they were painted in the original building, so we could also use concrete. So we were provided with the files. The Geiger company was basically providing us with a 3D model, which was scanned on site. And we can show this video that actually explains a bit, can you turn down the sound? Shows the reinforcement. So we are only printing the basically form generating elements, then it's casted, then it's decasted, and you see the element coming out as it is. And this was already the assembled arch that we basically installed directly on site. Yeah, and all the other segments that were necessary to actually build these 5 windows that we had to reconstruct. So this for us was an understanding that the need was definitely there. And actually the contract was given to us because there was no other company able to produce these in a very short time. So we could directly start with the printing, and the molds were sent to the casting company, a prefab casting company, and they produced our segments. Here you see a detail of how we printed the part. This was one of the arc elements. Yes. So we have our 3rd chapter, which ties into a lot of topics we addressed already now. We wanted to go more into these positive, let's say, factors of how 3D printing can change the building industry. So sustainability in that respect is a very big topic. I'm not going to go through all the details. We're going to start basically with a small diagram which explains it really well, which is derived from the research that I was busy with in the time before BigRep. So at the moment, you can see what we have on site is a so-called mass active elements. So we have a rectangular casting elements mainly who are producing elements in concrete on the cost of a lot of concrete. So basically, a beam is not optimized, it's just straight, even though you could have less material on certain parts, you're just casting in because the process on site is more easy. So we see the 3D printing more in this area where we're actually moving towards so-called form active buildings. So yeah, we see domes and structures which we have also seen in the Sagrada Familia, which work from a really structural point of view, but use less material. So we call them serial unicards as well, because maybe in this object all the different segments are unique, but through to 3D printing you are enabling this freedom now to design. So this definitely leads to the fact that actually using less concrete in structures that you can now design.
Well, so far since the 1990s, especially when the advancement of digital design tools reached architecture, people started to design free-form, different geometry buildings. The only way of building it so far has been CNC milling, using huge forms of styrofoam and just milling them into formwork for precast elements, one at a time. And as you can see here, one of the groundbreaking buildings was Frank Gehry's Zollhof building in Düsseldorf, which was the first one using individual wall elements. Everyone was different, but it came at the expense of having this huge CNC machine. And of course, everyone claimed all the styrofoam that was actually milled away was sort of was captured with a vacuum pipe system, and it was all, but what do you do with a lot of styrofoam dust, I would almost say. So of course, the only way you can do it, you use a lot of energy to produce new styrofoam from it, and of course it loses quality all the time. So any sort of differentiation in geometry results in a very expensive production process and in a lot of waste. And that is something which where we finally can overcome the paradigm of the industrial age, that you have to produce a large amount of repetitive elements, because we can change the process of production.
Mm-hmm. So yeah, and this circle we have shown before, so this ties exactly into this, to say we're actually only printing what we really need in terms of getting the geometry that we need, and we're enabling through a higher quality of the material, better than a polystyrene base material, we're enabling a good possibility to recycle this material and reuse it in a good manner. So these are, let's say, very short described all the topics that we put together today in this webinar. We have a Q&A version or let's say round now. So Abby, I think you are back to post the questions for us because you collected them.
And we do have quite a few questions that have come in, so I'm going to start answering them right now. If anyone else has any questions, please feel free to type them in, and like I said, we'll try to get to as many as we can. All right, first question up, here we go. This one is from Alex. Will 3D printing take a major role within the construction industry? What do you two feel is your thoughts on that?
Yes, I think I'm going to take that one for sure. We are convinced that the role of 3D printing within construction will pick up and will be even stronger than what we have showed now. We believe that this is just the beginning of a movement or of a technology that is embedded in the whole process. I have luckily some slides in the backhand that are addressing a lot of different topics where actually we can relate to. So I'm just gonna browse quickly through that. And then this is a very nice, let's say, research from Boston Consulting Group, an analysis on what are the topics in construction for 3D printing right now and what are the tasks in the future. So basically you can see on the left-hand side all the different components. We talk about full buildings, we talk about bridges, also molds, exactly the topic we have shown today, and building components. And for sure, as you can see, architectural models, they are already part of the practice. So architects using 3D printing to have representative models of their designs. And so that process is already finished. So the green bars are always showing when is it introduced to the market and when is actually the high point of the development finished and it's actually common standard. So if you see interior design, what you've seen, the chair that Angela Merkel was holding, this is already happening. You can already print chairs. This is not a topic. They're functional, they can be used. Also more or less done. For sure, we have some more 2 years to make it to perfection. And as you see, looking at the molds, what we've showed today, the formwork, it needs some more time to get there, to actually have the material performance, to have the speed of the printer, to actually maybe look at the post-processing. So there are still some details to cover all the range of applications. But as you could see, we already have a valid portfolio of projects where it works. And for sure, if you look into the bigger parts, like bridges and whole buildings, we all see the development of printing concrete directly. This is happening. So it's every technology will basically have its own use, but for sure it will take a major role in the 3D in the construction industry. I'm pretty convinced of that.
Okay, great. All right, next question up from Ryan. He said, thank you for the great presentation. And he also asked, what are the advantages of 3D printing? So I'm thinking he meant in terms of speed, time savings, design time, all that kind of good stuff.
Yeah, maybe let me take this one. I think it's great that, you know, in the Renaissance, we started to see the divide between the people who are making things and the people who are thinking about some things or actually are designing some things. And basically all these techniques, especially 3D printing, will help to bring the two together in a much, much closer way. So on one hand, we have people designing buildings, but we can now also have a much closer interaction with the design of different building processes, which allow us to work in a circular way, as we were trying to explain, that you get information from, you gain insight from the way of manufacturing these molds, which you can apply to changing the shape immediately. And that is actually only due based on the speed this technology can provide. So we can make a test. I mean, we always build for bigger projects, we always have to put up mock-ups and you look at the mock-up together whether something works or not. And that usually takes a very long time. Then sometimes there's not enough time to learn from your mock-up and to really apply this for the entire project. Now, the process of building prototypes and mock-ups is already embedded in the design process. So in the end, the design and the realized project are much closer together. Process and project will be really one thing. And that's a great, that's great potential for every designer or any architect.
Great. And this one kind of goes along with this. Todd asked, do you have to design differently with 3D printing? What are some, from my side, what are some tips there that you can share with our viewers as well in designing for that?
Yes, definitely. I mean, you have to design having the knowledge about the technology, how to fabricate it. This is a very crucial, let's say, key aspect of what Tobias was now talking about, to bring these closer together. For sure, you need to get an understanding of how you make them. So you need to know what the printer can do and what not. And in order to actually design something or come up with a design that's maybe completely different. So looking at the furniture is always a good example. If we are looking at the Ocker chair that we have designed, this is made for really 3D printing. It's not made for injection molding. And actually it cannot be done with injection molding. I can have a short, can show you a short image of that, because I think it describes it really well. So the design is made that you don't have the support structure that normally you need in order to print, let's say, overhangs. You're actually skipping this in this project because the design's already made in a way that you don't need support. Or if you look at the knot like this one here, if you would imagine you have to do this chair with the mold and injection molded, how do you get the mold out? It will never be possible. So this is a very good example for how 3D printing changes your mindset and how you design, and then you actually come up with the real, let's say, advantages of 3D printing. So it's not about copying what we've been done so far with other technologies and just printing them. It's really about looking into what can you do new and what can add to the function of these objects.
Okay, great. And this one kind of keeps going along that same path. What other applications do you see? And do you see 3D printing kind of taking a more dominant role? Do you see it as a support tool? Is it going to replace things? Where do you see its role going forward?
Well, there are a lot of developments at the same time, and I think one of the main drivers we have in the entire construction industry is actually the need to reduce the amount of resources we spend to build our buildings. And in that way, for instance, concrete is not the most efficient material. But with the help of 3D printing, we can start to think about molds in a different way, as we said, and ultimately we'll probably also have alternatives to concrete, different materials which can be used and which can be processed within molds which might have been 3D printed. So it gives us the opportunity to combine materials which have a much lighter footprint actually and a design which, as Jörg showed, is much more intelligent in the way it directs the flow and the forces which are at work. And in that way, it's an optimal bridge actually between the design which we're doing at the moment, and actually we're using that for models, but then also going into the next step towards, let's say, even materials, which are just in a testing phase at the moment.
Yeah. All right, we've got time for one last question. All right, guys, get out your crystal balls. 3D printing, you know, has been around for quite a long time, but where do you see it going? Where do you see the next cool thing? What's going to happen in the next 5 to 10 years?
Yes. I mean, I can take this one. Basically, as I said, bringing in new designs, looking at it in a different way because we have new possibilities. I think what we haven't addressed today is a huge aspect of 3D printing is the functional integration. So we see a lot of possibilities and potential also in 3D printing to adding new materials and new material combinations into certain objects. So we've created a modular wall. You can see this also on our website, on the YouTube channel, where we're basically printing a sensor into the surface of the wall, where you can control the light of the surface. So you basically, or the light of the whole wall. So in the end, you're now able to actually produce 2 different materials in one process, which at the moment is not able, so you always glue it on top, or you have an additional process that brings it together. So there I see still a lot of potential for the construction industry, and I also see a very great potential in modularization. So basically at the moment, modulars or standardized buildings are always considered very boring, but actually 3D printing could make the gap now and close the gap and say we can actually design a knot or a construction where basically points come together, like you see it as an example with this chair. You could now modularize much more interesting components and create kind of a standard building, but with some elements which are unique and uniquely designed and produced. So I think the end of this development is not there yet. We're just at the beginning. And for sure, you see a lot of hype on printing concrete directly. This will also be there on the market, but the molds, having the formwork to create a certain surface texture, to create let's say an artistic surface that you need. For that, you will always need the molds. So I think it's a combination of different techniques coming together on site, and the formwork part will be always there, even though we will print concrete as well, or we're already printing concrete directly.
All right, great. Well, it looks like we're almost out of time. And again, my apologies if we didn't have a chance to answer your questions. We'll follow up shortly after. Jörg, do you have any final tips before we maybe jump back to that wrap-up slide there?
I'm basically fine. Do you have anything? Do you want to add something?
Well, we're looking forward to everyone exploring the potential. I think that's best. That's something which is best done by a big crowd of people.
Great. Thank you, everyone, for joining. We appreciate you being here today. And just a reminder to follow us online. We're on Facebook, LinkedIn, Twitter, and Instagram. And also be sure to mark your calendars. September 6th is our next webinar. And again, thank you for joining us. Thanks you to Jörg and Tobias for being our excellent presenters today. And we hope to see you next time. Thanks and have a great day.
Thanks. Bye-bye. See you.